All right, so this is going to be a video all about simplifying imaginary numbers, and I have 5 examples right here that I'm basically going to be working out in this video, and hopefully it makes more sense in understanding how to simplify imaginary numbers. Okay, so this first one is, I'm just going to rewrite it over here. To simplify this, it's actually really similar to simplifying radicals, only this time we have a radical factor that's I. That's the square root of -1. If you remember in a previous video, we talked about that I is equal to the square root of -1. So you're going to want to factor that out so you end up having an I on that. So that's actually the first thing I'm going to do. So I'm going to rewrite this here and just by factoring it. So it's going to be times the square root of -1 times the square root of 45. Okay, so if you notice the square root of -1 times the square root of 45, here, I'm going to highlight this. So if you notice this part right here is equal to this part right here. Okay, I just factored out that -1. Now what this allows us to do is now I can rewrite this to be -3. This is equal to I, this part right here that I just underlined is equal to I, and then you just do times root 45. Now we're not done yet because you still need to simplify this radical right here, this square root of 45. So to do that, what I'm going to do is try to think of any perfect squares that are within that 45. And for this one in particular, it's got a 9 in it. So what I'm going to do is rewrite this, only I'm going to I'm going to factor out that perfect square radical, which is the square root of 9. Okay, square root of 9 times the square root of 5 is equal to the square root of 45. And so what I'm going to do is actually just kind of highlight this so you can kind of see the highlighted orange parts are equal. So everything I've done so far is equal. You can kind of see how I highlighted it, how I factored things out, that sort of thing. From here, we can turn that square root of 9 to a 3. So it's going to be -3i times 3 times the square root of 5. Okay. Now from here, I'm going to combine the 3 and the -3 here to get -9i times the square root of 5. And this is the final answer for that first problem. Okay, I try to break it down step by step and highlighting it. But if you do have any questions, definitely make sure you ask in class for this problem. So the next one we have the square root of -4. And the whole quantity of this is squared. First thing we're going to do is, if you notice, the square and the square root are actually inverses of each other, so that kind of makes it easy. You can just kind of cancel these out and you're left with -4 as your final answer. But let's say you were not that clever and you weren't able to actually see that you could just do that right away. You could still do this the way that I just did it previously, using imaginary numbers. So let's act like we didn't do what I just did. So let me undo all that. All right, now the square root of 4, what I'm going to do, or the square root of -4, is I'm going to factor out a -1 out of there. So now we have the square root of -1 times the square root of 4, and this whole thing is still squared. Okay, from here we have this square root of 4 ends up being 2. This square root of -1 ends up being I. So I'm going to put an I times 2, and this whole thing is squared. Now from here, it's going to be 2i squared, which is just going to be 2i times 2i. Okay. Well, 2 times 2 is 4, so I'm going to put a 4 in there. And then I times I is I squared. And we went over this before, but I squared is just equal to -1. So I'm going to put a -1 in there, and you get -1 times 4, and you get -4, which is similar to what we got the first time when we were looking at this problem, and we just go, oh, we can cancel out the squared and the square root, and you get -4. So if you notice, the answer does match. I just kind of wanted to show you 2 ways in case you were thinking about doing this by factoring out that I. Next one is the square root of -200x. So I'm going to write that over here. So we have -200x, and we're doing the square root of this. Okay, I'm going to zoom in over here now. All right, so the first thing I'm going to do here is I'm going to factor out that I. Okay, so I'm going to write the square root of -1 times the square root of 200. I'm also going to factor out that x just to make it a little bit easier. So factor out the square root of x. We have something like that. Everything's factored. Okay, we do need to simplify this square root of 200 here. I'm going to turn that square root of -1 to an I, and I'm thinking of any perfect square that's in 200. And in this case, I'm going to just do 100 because I know 100 is a perfect square for this. It's going to be 100 times the square root of 2 times the square root of x. Okay. And if you notice, the highlighted orange parts are equal. These two are equal right here. Okay. The I drops down again. This square root of 100 is 10. The root 2 can't cancel out any further, and then we have root x over there as well. Okay, everything is completely broken down. You can't break down anything any further, so I'm just going to kind of rewrite this whole thing now. So it's basically going to be 10 times the square root of 2x times I. It is really important to understand that the I is not underneath the square root, so you don't want to mess that up. I did combine these two because they're the only square roots left, so you can combine them. If you recall from previous math courses, you're allowed to do that at the end to fully simplify the problem, and you end up with that as your answer. All right. Next, we're going to have the square root of -121 times x to the 5th. Okay, let me write that down real quick. All right, so the first thing we're going to do for this problem is the same thing we do for the other ones, is we're going to factor out that square root of -1. So square root of -1 comes out, and then you have the square root of 121 times the square root of x to the 5th. Okay. From here, I'm going to turn the square root of -1 to I, just like we've done before. The great thing about this square root of 121 is that it's a perfect square. So it's just going to be 11. And then this one here, we're doing the square root of x to the 5th. We need to figure out how many perfect squares are in that. Well, the perfect square that I'm looking at here for this one is going to be x to the 4th. X to the 4th is a perfect square, but we still need to multiply it by the square root of x as well, because the square root of x to the 4th times the square root of x to the 1st is equal to the square root of x to the 5th. And just to kind of show that more visually, I'm going to highlight it. This thing that I just highlighted in orange is equal to this thing that I just highlighted in orange. Okay, I do want you to see that. Okay. Keep going here. Okay, the I times 11 is going to be 11I. Okay, the square root of x to the 4th is just x squared. So that's x squared. X squared times x squared is x to the 4th. So the square root of x to the 4th is x squared times the square root of x. Okay, so if we're going to simplify this completely, I'm sure you're fine with just leaving it like this, but usually the I does go at the end for whatever reason. So it's going to be x squared times, it's going to be 11 times x squared times the square root of x times I for your final answer. Okay, that last one is the square root of -25 times the square root of -4. All right, first thing we're going to do is what we do every time, is pull out that square root of -1. So I'm going to do that for the first one, times, and then I'm going to pull out the square root of -1 for the second one as well. And what this allows us to do is see where our i's are. So we have an I here and we have an I here. Okay, the square root of 25 is just 5. The square root of 4 is just 2, so that makes it easy. So we end up having 10 times I squared. Well, I squared, if you remember, we went over this before, is equal to -1. So your final answer is going to be 10 times -1, which is just going to be -10. Now for this one, it is really important to understand that you want to factor out the i's first for each of these. Okay, in the old school way of doing these, some people might have combined these right away to get the square root of 100, because a negative times a negative is positive. But the problem with this is you would get +10, when it's definitely not going to be +10, because we have imaginary numbers. You're going to, if you multiply them together, you should end up with a negative value. So you cannot just combine the -25 and -4. That only works for positive, for when you're taking the radical of a positive number. That's the only time it really works. So you are going to want to break down kind of what I showed here rather than just setting this equal to negative 25 times negative 4 in the square root. Do not do that because you will get the wrong answer every time. So that's basically a video on example problems involving simplifying imaginary numbers. If you have any questions about anything in this, video, let me know.